So greetings for the day. Myself Dr. Akanksha Dubey, Assistant Professor at Christu Jayanti College, Bengaluru from Department of Life Science. So today we'll be studying about reaction mechanism. So what is reaction mechanism? Reaction mechanism is step-to-step description of how any reaction occurs. Now reactions can be of several types. Main organic reactions are divided into categories like addition reaction, elimination reaction, substitution reaction and rearrangement reaction. Addition, as the name suggests, when two molecules combine to form adduct or a third molecule. In elimination reaction, some functional group or group of compounds gets eliminated to form another product. In case of substitution, a functional group substituted by another functional group to form a new product. And in rearrangement, a carbon skeleton rearranges itself to form a structural isomer of the same compound. So all of these reactions, whether addition, elimination, substitution or rearrangement, it may take place either in polar mechanism or through free radical mechanism, which we'll be discussing in subsequent classes further. Now polar reactions may be electrophilic or nucleophilic. Talking of types of organic reactions, so here we have different examples for all four different types of organic reaction. So here, as you can see in the first example, that is substitution, here bromine is getting substituted by hydroxyl group, whereas in case of addition, as I told, two products gets added up to form an abduct. So here, as you can see, bromine gets added across a double bond to form a dibromo product. In elimination reaction, again as I mentioned, a functional group is eliminated. So here water is eliminated to form a double bond. And in rearrangement, the molecular skeleton has been rearranged to form a structural isomer of same compound. Now talking of steps in the reaction mechanism, so here bond breakage or formation can be symmetrical or unsymmetrical. When we talk of symmetrical, that means homolytic cleavage, and when we talk unsymmetrical, that means heterolytic cleavage. Now here the first example is of symmetrical bond breaking, where one bonding electron stays with each product. So here when we talk of homolytic cleavage or symmetrical cleavage, it clearly means that one electrons will stay with one product. Now in case of unsymmetrical bond breaking, in second example, you can see two bonding electrons stays with one product. So here one thing more important to observe is that if it is half arrow curved head, it indicates homolytic cleavage. If it is full, it indicates heterolytic cleavage. As an example of third and fourth, you can see symmetrical bond making or radical mechanism occurring in the reaction, where one bonding electron is donated by each reactant, whereas in the fourth example it is unsymmetrical bond breaking, where two bonding electrons are donated. Next, we have examples for addition reaction. We have halogenation reaction, where ethene gets halogenated by bromine to form a dibromoethane. Hydration reaction, where hydration occurs, that means addition of water to ethene to form ethanol. Again, we have hydrogenation, addition of hydrogen to ethene will give ethane. And we have polymerization, where vinyl chlorides gets polymerized and gets added continuously to form polyvinyl chloride. Next, we have example for substitution reaction, where chlorine gets substituted in the structure by removing hydrogen in the presence of a Lewis acid, which is termed as AlCl3. Now here we have another example for substitution, that is when methyl chloride is reacted with the hydroxyl ion, it forms methanol and chlorine groups removes, and again reaction with ethanol with hydrogen iodide forms iodoethane along with water. Next, we have example for elimination reaction. So here you can see the chloride group gets removed, and HCl, after alkyl halide is removing HCl from it, it forms alkene in presence of NaOH, ethanol and heat. Next example for elimination reaction is when ethanol gets dehydrated to give ethene by heating it up with excess of sulfuric acid at around 170 degrees centigrade. Now here, instead of sulfuric acid, we can also use phosphoric acid. So here, as you can see, CH3CH2OH will form alkene, that is CH2CH2 ethene, and water will come out. So this is clear example for elimination reaction, where water gets eliminated. Next, we have examples for rearrangement reaction. So here we can see clear rearrangement in the structure, where the Curtis reaction involves the heating of acyl azide, which loses the nitrogen and again rearranges itself to form a isocyanate. Now here, as you can see in the reaction, RCON3 will form RNCO plus N2, where nitrogen comes out, and here you can see Plus charge indicates carbocation, where methyl group will get added and form donates its electron to the carbocation to form a shift or a rearrangement in the structure. So that's how we can say that Curtis reaction is clear-cut example of rearrangement reaction, where it rearranges itself to form a structural isomer. Thank you.